My name is Jacob Scriffiny, and my team this semester worked on the project running large models on small mobile devices. And our team was specifically tackling how we could expand the OpenRTiST platform to mobile-first processing. So a little bit of background on the motivation behind this project is that a lot of the time, heavier computation tends to be offloaded to the cloud because it's too difficult to run on mobile devices due to hardware constraints. And so our project wanted to see, could we take the existing OpenRTiST project, which essentially takes a deep neural network model and applies a stylistic artistic transfer real time to the frame. So in layman's sense, it takes the world around you and transforms it into a piece of artwork. And so we'll first show what the existing implementation accomplished. So right now, this is on an Android device, and you can see right now it's just plain capture. And here we can come and choose an artistic style. And here this is the mosaic style, so you can see in real time it's capturing the world around us. And this is offloading every single frame to a cloudlet here in Carnegie Mellon. We're just on Carnegie Mellon Wi-Fi. And you can see the latency is okay, and we'll dive into the details later. But this is all offloaded onto the cloud. Now, our implementation, we took all those original models on PyTorch and converted them to Core ML, and we created 3 quantized variants, FP32, FP16, and int8, with various sizes so that they would be able to run more efficiently on the device. And then we have automatic hardware delegation, and we also have a lot of controls on our interface to improve the performance. So now if you want to see our application, so this is on iOS, this is running on an iPhone 13 Pro. We have the same set of styles, and you can see here we can select any style. Here we have different resolutions. So on this resolution, you can see the text is a little bit more clear, and we can even select a very high resolution, and the text is even clearer. And at the top here, you can see that our frame rate and our latency suffer as we increase the resolution. So here we just went back to the 256 by 256 because this tends to be one of the most stable runs. And here on the configuration center, you can also choose different quantization and different hardware delegation. So you could choose floating point 32 and have it run across all the hardware on the iPhone, or you can choose FP16, which tends to perform a lot better than FP32. And just to show a variety of the artistic styles, you can see we set up an automatic switcher so you can see how the styles change. And now for the comparison between running it on the device versus the cloud, so on the bottom, it's running on the cloud, and on the top, it's running directly on our phone. So you can see at a resolution of 288 by 512, it's pretty similar. But if we were to go a much higher resolution, you see on the bottom, this is the cloud, it runs much better than on the device. The device, you can see, has much higher latency and a lower FPS. But if we were to go back to the simplest resolution, we see that the device actually operates a little bit better. So in terms of our results, we found that at a lower resolution, the phone performs much better in terms of FPS, in terms of latency, and the power drainage is comparable to offloading to the cloud. Whereas as you increase the resolution, we see that the cloud starts to outperform locally, and it has lower latency, and the device does not suffer the power drainage as it does with a lower resolution. So that sums up our project, and we hope you enjoy. Thank you.
All right. Tell me what we're seeing.
Okay, so what we're seeing here on the bottom is an Android device running the OpenRTiST platform, fully delegating the offload to the cloud, whereas on the top, everything is running locally on the phone. And as we turn the phones, we see that the local version actually runs a little bit more responsive than the cloud version. And this is one of the big breakthroughs that we were able to do using Apple's hardware. They have the Apple Neural Engine, which makes lower resolutions a lot more efficient than having to delegate off to the cloud. And as I'm holding the phones as well, I also feel the Android actually getting fairly hot, whereas my phone's temperature seems to be relatively stable. So this just goes to show that for stylistic transfer at lower resolutions, the local device itself tends to be a better option for the cloudlet and leads to future potential investigation into how can we adaptively either offload to the cloud or run models on devices based on the device constraints.